All right, guys, here we go. Question 3 from the grab bag. Hopefully you've read the question. If not, let's do it. A container with a square base, vertical sides, and open top is to be made from 1,000 square feet of material. Find the dimensions of the container with the greatest volume. Verify your answer with either the first or second derivative. All right, let's see. We have a container with a square base and vertical sides. Sound familiar? Maybe something we did in pre-calc? Let's get a picture. You guys know how good my pictures are. Let's see. I have a container. If the base is a square, then what does that tell me about the length and width of my container? They have to be the same. So you want to label them with the same variable. The height is some other dimension, therefore I have to represent it with a second variable. It's not the same size as the length and the width. Now, we were told that we have 1,000 square feet of material. What does that represent? What is that telling us? Well, remember, use your units to help you. It says it's 1,000 square feet. If the units are square feet, then that has to be area. However, because we have a three-dimensional box here, that must give us surface area. So they're giving us surface area for some reason. We're going to have to come up with a formula. But the question is asking us for the greatest volume. Therefore, we are trying to maximize the volume, which means we also need a formula for volume. Now, hit pause, see if you can come up with those two formulas. Okay, hopefully you hit pause and came up with your formulas yourself. Volume should be length times width times height, x squared y. Surface area is just the area of all the sides added together. And the bottom would be x squared. There's only one because it's an open top, plus 4xy, which is the area of each of the sides. Now, with this formula here, if I were to take a derivative, I would need the product rule. Doesn't sound like too much fun. That's why they're giving us the surface area. The surface area is 1,000, so I can use that to solve for y, sub that into volume, and come up with a formula that's all in terms of x's. So what I want you to do, hit pause again and solve for y, plug it into volume, and I want you to simplify that volume formula as much as possible. It will make taking the derivative easier. Hit pause. Okay, let's see here. Hopefully you've come up with this formula on your own. This is me solving for y. Subtract x squared, divide by 4x. I'm subbing that into my volume formula. I want to simplify. I'm going to cancel out that x right there. So I've got volume equals x times 1,000 minus x squared over 4. I want to keep simplifying this. I have to take a derivative. Get it as simple as possible. So what I end up with, volume is 1,000 over 4x minus x cubed over 4. If I distribute the x and then split the fractions, well, what's 1,000 divided by 4? That's just 250. X minus x cubed over 4. Nice, simple formula. Now we are ready to derive. Remember, if we're trying to maximize the volume, you want the volume derivative to equal 0. That's what we're trying to do so that we can solve for x. Let's get a derivative. Volume prime equals 250 minus 3x squared over 4. What do you think about that? Now, I want my derivative to equal 0. If you want, go ahead, hit pause again, and I want you to go through and solve for x and see if you can get an answer. Okay, hopefully this is the work that you did on your own. Add 3x squared over 4 to the other side. Cross multiply, 1,000 is equal to 3x squared, divide by 3, square root, x is equal to the square root of 1,000 over 3. That sounds lovely. On my calculator, if you remember what those are, 18.257. That's what I've got. Now, to verify my answer, I think if x is 18.257, that will give me the greatest volume. That's what I think my answer is. I need to verify. Second derivative test. v double prime equals, remember, look back at your first derivative and take a derivative from there. It becomes, let's see, the derivative of 250 is 0, negative 6x over 4, which is equal to negative 3 over 2x. Now what I'm doing is I have to sub in what I think my answer is for x and see if that is actually a max. Second derivative of 18.257 equals, well, if I'm subbing this in for x, I have a negative number times a positive number. My answer is going to be negative. Therefore, my function is concave down. Therefore, it's a max. Perfect. That's exactly what we wanted to happen. Now, the question is asking us to find the dimensions. Therefore, our answers have to be x and y. I already know what x is. I already found that answer. What I need to do now is take that answer for x, sub that back into y, and get my final answer. So, let's see. X equals 18.257 and y is equal to 9.129. These are both measured in feet, and those are your final answers right there. You've got dimensions for x and y. What do you think?